credibility of WAEC, but at an extent, not in this sort analysis. Okay, I don't know what they were expecting students to get by hitting a feature. Don't worry about what you are manipulating. All of them. These are common fountain gases used in fountain experiments. So, and I said I have videos on this fountain experiment where I've used that of HCl, ammonia fountain. So they have different colors, of course. Then this is Her Majesty Easy World Science Channel, of course. Let's feel. This is Her Majesty. Then other names, should be Easy World. Science Channel center number. You contact us with this number 166217 in case if you need extra services, and remember it will require extra payment. Okay, but here we are going to serve you free. Make sure you ask your questions where necessary. We'll take a look at the questions, their answers, and the possible review for this concluded alternative A chemistry practical 2024. Okay, so we will move to the first page, or rather the second page. Okay, this is the titration. As usual, the English, all burette readings, initial, as well as all this, is just all calculation must be done in this booklet, just for students that will assume that the examiner knows. There are rules. Putting units, putting the volume of pipette used, avoiding arithmetic error. Okay, so they gave us that A is a solution of KMNO for after everything. The first thing we're going to do, the first question, which is A, they say we should put A in a burette, and after everything, we were told to tabulate our burette reading. We're going to tabulate the results, so we need to make a table as usual. So in this table, this space is even too small, but let me manage it. So we will have burette reading. Have rough first, second, volume on top of the table, pipette used 25.00 cm cube. Just secure mark. Now I'm going to fill this table. I'm going to use the endpoint that might not rhyme with what your manipulation will take. Let me not call it manipulation, but let me fill here. Endeavor to watch my review, the video on the review on this practical, and see why I made some choices. Remember, this is Her Majesty Easy World. I am a practical oriented, not just an exam channel. Like Africa is so much focused on the exam than the science. We want certificate more than we really need the science. You struggle for A1 in chemistry, but you cannot perform anything practically up to even C5, and it's not helping our nation. It's high time we go back to the drawing board and take a wiser decision. Okay, maybe this first rough. Remember, you can also put units under this title, that's burette reading, if you like. So here, my rough from the experiment I conducted, my rough was 10.80. I'm going to assume that the initial is 0.00 here, but unfortunately I used one burette to run the whole titration, but I couldn't remember those values, but I knew that the final volume of AU, so 10.8 minus 0.00 still remain 10.80. Here is 0.00. My first title was 10.00. So here is 10.00. Second was 10.20, 0.00, 10.20. Then the title was 10.10, 0.00, and 10.10. So this is the table. We have concluded the table. Now, some are using 18 with reference to this equation they gave with regard to the equation. So some are using probably 18 to rhyme, but we are talking about practical, non-manipulation. The question is iron 2 sulfate and hydrous or hydrated? You watch my review on this WAEC and this particular practical. I conducted the experiment very well, and for those that followed me up, you can see I'll show you my predicted question. That's what you can see there on the screen. Of course, my number 2 was exactly what came out, so only that they changed the I made mention of tablet, but over here they use granules, but in that my likely question I said tablet. Okay, so this is why when we are guiding you, it's a matter of experience. So paid services are not like just free ones. So experience really matters. So I indulge chemistry teachers, if you are still not strong enough during a practicals like this, you contact Her Majesty. I'll guide you very well. My predictions are perfect, and remember that this experiment I've conducted it more than a year ago, even before WAEC brought it. So I am there before they come. Not that because I saw their instruction paper before starting the analysis. Okay, so that is by the way. Let's go to the subsequent calculations. Yeah, this is the first calculation that follows, which says, from your result and information provided, calculate the concentration of B in mole per dm cube. Conc of B in mole per dm cube. Since B was given as granules, we are not specific. Therefore, what we are going to use is CAVA all over CBVB. Remember, if they labeled your A C, it will now be C, CC, VC. If it is labeled E, like for alternative C candidates and alternative B candidates, remember that their acid will be labeled D and their base will be labeled E and their salt probably F. So, but if you use CAVA for that one, when it comes, we'll still guide you where CAVA over CBV equals NA over NB. What's our CA? It has been given, they purposely made it 0.02. It's given in the equation times VA is the endpoint, which is my own. Although, sorry, I didn't determine the average volume of A used because of space in the other one. So average volume of A used, pardon me please, the soft copy of this I provided doesn't have this enough space. So the average volume should be 10.00 plus 10.20 plus 10.10, all divided by 3. At the end, we will have 30.30 divided by 3, divided by 3 of course, which will give us 10.10. Yes, so the average volume of our VA is automatically, VA should now be 10.10 cm cube. That's what we are told to do. So that's why what I will put here is 10.10. Then divide by CB is what they asked us to find. VB I used 25. Na is the mole ratio of the oxidizing agent, which is KMnO4. That should be 1. The mole ratio of the reducing agent, which is iron 2 iron, that's 5 moles of it. So we have 1:5. We cross multiply. At the end, we have that CB is equal to 0.02 times 5 times 10.10. Remember, don't say 10.10. in mathematics is incorrect. All over 25 times 1. So we will go to the calculator department. 0.02 times 5 times 10.10. Okay. 0.02 times 5 times, it will give us 1.0100. So we have 1.0100 divide by 25, all things being equal, 0.040. So CB here is equal to 0.0404, if I can remember well, mole per dm cube. Remember to put it. So we move on. The next question says concentration of B in gram per dm cube. I still don't have enough space, but I will manage the space. B in gram per dm cube will require us to revisit what they said about B. I can't recall, so permit me. So they told us that B is actually 3.8 gram of the iron in 250. So, and they are looking for B in gram per dm cube. So remember, we cannot use the formula which says that mole per dm cube is equal to gram per dm cube all over gram per mole. Reason is because they said granules. They weren't specific of the nature of the granules. Nobody know the molar mass of B. So molar mass, gram per mole, is not possible, and we cannot solve two unknowns. So therefore, we are going to use what they said here. 3.8 grams is in 250. How many will be in 1000? That is the mass concentration of B. So here we continue. Since B contains, since 3.8 grams of B is in 250 cm cube, we have that X will be in 1000 cm cube, such that we have that 250x, we have to cross multiply, is equal to 3.8 times 1000, and then 3.8 times 1000 should be 3800, if I'm correct. Yes, of course. So that 250x is equal to, I'm managing the space, is equal to 3800, such that x is equal to 3800 divided by 250. And going to our calculator department, we have that 3800 is 15.2 gram per dm cube. So the strength is 15.2 gram per dm cube. You should have these values. So 15.2 gram per dm cube is the concentration of B in gram per dm cube. And remember, you write answer so that examiner will know you have reached your final answer in each case. So we will take a look at, go to the next question, and this is the exact III. Maybe it's not clear. The III says mass of iron 2 ion in 250 cm cube of B. Mass, let me recopy it. Mass of iron 2 ion in 250 cm cube of B. So this works very, very well. So we are going to find out, they are calculating, they are asking us for iron 2 ion this time around, not the whole B granules, not the iron 2 granules or the iron granule, but they are specific now. So looking at this, we'll have to go back to our CB. That's the concentration of the iron 2 granule itself, which is 0.0404, if I can remember well, mole per dm cube. Maybe I will check my history here. Yeah, 0.0 over here, 0.040. So it's correct. Go back. That is mole per dm cube, meaning this is the mole present in 1 dm cube of it. And this is assumed that for them to ask this question, it shows that the granules will have equal dissociation, which means 1 mole of the granule will automatically give us 1 mole of the iron 2 ion. If it is so, if it is not so, the question will not be there. This thing implies that 1 mole of B will dissociate to give us 1 mole of iron 2 ion. This is the case here. So since this is true, we will take the strength of the CB as also the strength of the iron 2 ion in 1 dm cube. Therefore, we have to say 1000. Remember that 1 dm cube means 1000. 1000 cm cube contains 0.0404. What will 250 cm cube contain? You call this place x, cross multiply. So from this, we have that 1000x is equal to 250 times 0.040, such that x alone will divide both sides by 1000. Divide by 1000. This will cancel, this will cancel. So from the calculator department, we have that 250 times 0.404 and divide by 1000, if I'm not mistaken. Is equal to 0.01. 0.01, of course, is correct. 0.010. It's just all about using a cheat, but this is a WAEC. You have to show all the working. 0.0101. It's just dividing this thing by 4 because 250 is a multiple. It's 4 times that of 1000 mole per dm cube. Remember, okay, not per dm cube now, mole per 250 cm cube. Sorry. So since the equation has already specified 250 and what we have here is 250, we just say answer. Moles. This is our final answer. If putting 250 on it, then percentage of iron 2 ion, that's question IV. Percentage of iron 2 ion in the granules. Remember, this is Her Majesty's Easy World, so please, if you have not subscribed to this channel, endeavor to do so. Subscribe and share, and most of you that have been there for us, I really appreciate you guys. God bless you so much. But let us focus more in science than in certificates. Science will save the nation. Certificate will remain with you. It will not do anything. I don't know if you have heard about Professor Dr. Michael Faraday, double Professor Isaac Newton. Those things never existed. They are scientists and they are the people we are looking up to. Africans are great. But the way we are so much focused on this is funny. You don't equip your laboratory. You just believe in manipulation. You be calling left and right. What's the end point? How do we do this manipulation? We are killing the nation. We are killing our future. Invariably. Proprietors of schools don't buy any apparatus from us. It's only few that do buy. So they believe doing it is a scam where we are there to manipulate. So these children, I think we are teaching them chemistry so that they will become chemists, not that they become, I don't know. But all the same, please let us support real science in Africa. Percentage of iron 2 ion in the granules. This time around, they are now going back to the granule itself. Percentage of iron 2 ion in the granules. If you like, you can speak in terms of okay, sorry, the question, I say mass. Now I remember, this is mass, which means this is not our answer. Since it's mass, we are going to convert the mole to mass by multiplying by the molar mass of iron. Therefore, to convert to mass, 1 mole of ion 2 ion, definitely remember electron doesn't contribute to the mass of a subatomic particle, whether ion, so it doesn't, whether it's lost, because this charge is showing that electron has been lost, so it doesn't change the mass. So the mass of ion 2 ion is the same thing as molar mass of ion. So 1 mole of ion is 56, such that 0.0101 will be what? X. We just have to multiply 56 by 0.0101. So that will give us the final answer. So to the calculator department, we will just say times 56, 0.5656, 0.5656. So our final answer is 0.5656 grams. That's the mass. Okay, percentage by mass of the granules. We can, if you like, you use 250. The granules has been mentioned that 3.8 is in 250 cm cube. The same 250 for this is for the granules, and the same 250 now contained 0.5656 grams of this time around of ion 2 ion. So percentage of ion 2 in the granule, if you like, you can take this over the total, because they are all in 250, or if you like, you can use the one in 1 dm cube, but they will give you the same answer at the end. So we are going to be concerned with these two values. The reason is because their ratio and the volume, they are the same thing. So because even if you convert this 0.0565 to dm cube, you need to multiply by 4, because we are talking about 250 here. So when you multiply by 4, you get the gram per dm cube. Then you can use 15.2. So but let's solve it two ways and see if I'm correct. 0.565 all over 3.8 times 100 over 1. So 0.56, is it 565 or 5656? Okay, it's there waiting for us. All over 3.8. You see it, 14.8, which will be 15% on the approximate, because we did not approximate to 6 times 100, that's 14.8 on the approximate 15. So 14.88, that's 14.9. So the percentage is 14.9%. Answer. What I'm saying is that if you like, you can decide to multiply this answer here, that's this 0.5656 by 4, and then use 15.2 that we previously got as the mass concentration of B. You will still get the same 15. That means if you say this number now times 4 divide by the 15.2 times 100 over 1, you still get 15 as the percentage. So this is it for the titration. Let's now see the salt analysis aspect. Okay, this is number 2. C is a mixture of 2 inorganic salts, one of which is a sodium salt. Perform the following exercise on C. Remember to watch my review on this. This is where I have many reservations, and I stand in for science. Actually, science is only for the truth, not for the title. Okay, after everything, as usual, we'll make our table, but I want to remind us that from the instruction followers sent to me, they told us that C is actually, maybe I used red, C was mixture equal by mass, not by mole, lead 2 triazonitrate 5 and sodium triazocarbonate 4. Remember, they are in the ratio of 1:1 by mass, not by mole. They are not the same thing. 1:1 by mole and 1:1 by mass are never the same. Why? Because the molar mass of the two compounds are not the same. Okay, so equal mass of equal mass of the lead nitrate will represent a separate mole of lead nitrate. The same mass you got in lead nitrate, you get it in sodium carbonate, it represents a separate mole. So, but the most reliable is maybe using equal mole at all. But all the same, I trust the credibility of WAEC, but at an extent, not in this salt analysis. Okay, put all of. I want to report. I will be reporting exactly what I observed by myself. Put all of C in a test tube and add about 10 cm cubes. So we need our table. Have test, observation, and inference as usual.
This is a little.
Okay, thank God we have enough space.
Mass. But the worst is to gain mass. Okay? So we have to remove. We're done with our weighing.
Serial number.
Keep this for filtration. So next, if you don't blend this, you're not going to get accurate results because it will be one-sided. So what you have to do is to blend. As the work, the functions of the pestle and mortar.
Observation column should be bigger.
This thing now, mix and mix and mix. I say we are okay. No, whether the size of the particles are not the same. So if you distribute this to your students, there will be high chance of somebody getting more of the nitrate than the carbonate. So it's advisable to use your pestle.
Alright. So we have the serial number. Here is text. You can use capital letter or small letter.
Kind of ticking, of course.
Observation.
So we have our pestle and mortar.
Then inference. The first thing they told us to do is to add C in a test tube. So C plus 10 cm cube distilled water plus filter, and you can say stir there. When you do this, there will be some people saying partially dissolves. Unfortunately, there is no they don't tell you to weigh the mass. If they report that way, they are reporting abstracts, but it partially dissolves actually. But there is no evidence you will notice on mixing this thing that it partially dissolves, because you still see a white powdery precipitate. So it is the filtrate that matters. You say white precipitate, sorry, white residue.
Alright, filtration is complete. Here is my residue. So our observation is
colorless
white residue.
Filtrate. So C
white residue
is,
and let's see the filtrate.
Mixture of soluble and insoluble salts.
Filtrate. Okay.
If the question called it salts, thank God they said it. So you report. If they say compounds, you say compounds. Insoluble compounds, say insoluble salts. So we are done with that. Some people will do over reporting. Some people will go and test with litmus. The question did not tell you to do that. Is it because your teacher told you, which your teacher is supposed not to tell you? Okay, then question B, this is question A. And BI says put about 2 cm cube of filtrate into a boiling tube and heat strongly. So what do we have? 2 cm cube of filtrate plus what? Strong heat. Observation: no gas evolved, filtrate boiled out. Watch my review here. Probably the test tube cracked because of uneven expansion. Don't know whether we are doing tests for glass here. I wouldn't know what they were expecting students to get by hitting a filter. Don't worry about what you are manipulating. I am answering what is obtainable. So watch down my review, or you can equally show me your reactions there. Remember, the filtrate is a mixture of sodium nitrate and sodium carbonate, but because you are the one that bases solely on theory, you say that the filtrate is sodium nitrate only. It's not true, because sodium carbonate was in excess, since it is 1:1 by mass. There are more moles of sodium carbonate, and that will make it go also part of the filtrate. So I heated this. I'll show you. I'm showing you this on the screen. On strong heating, what happened? The solution, the filtrate boils out. There was no remarkable gas evolved apart from the steam, and probably the test tube cracked. So filtrate boils out and the test tube cracked, and the tube cracked. It looks funny, but if Africa want to work scientifically, this is what is obtainable. Some of you are reporting a colorless gas evolved, which rekindled glowing splint. My dear, sodium 2095 is stable to heat. It is very difficult to decompose, not to talk of in solution form and in that little quantity. Small 2 cm cube of that spatula full of a mixture that will give you, or some will report reddish brown gas. I don't know. I don't know where it's coming from. The sodium carbonate that is also part of the filtrate is very much stable to heat. It cannot liberate CO2. So this is what I obtained in my own. Filtrate boils out, and the boiling tube cracks, or that the steam, it boils into steam. If you like, see that. You can say, then what should be inference? I don't know. You that know, you help me in the comment section. Then the next question there says that I put half of the residue into a test tube and add dilute HCl. BII residue plus, they didn't tell us any volume. They just said
from what WAEC
dilute
said. As you can see what
HCl.
happened
Neither
from
did they
that
tell
strong
us
heating.
any strength.
Isn't that funny?
Effervescent occurred.
Let's see.
Colorless, odorless gas
Remaining
evolved,
reaction.
which turns lime water
See, there is
milky.
effervescent, of course.
That's the only visible thing,
Colorless,
and the
odorless
white
gas evolved.
powdery precipitate remained in the solution. So we will have to report effervescence occurred, colorless, odorless gas evolved, gas turned lime water milky. If you watch that review, this is also questionable in practical. I gave my reasons in that review. Not that it's not possible, that's what we're expecting, but the question is, how can the child even bubble that thing into lime water, and the small gas released, that small CO2 will turn lime water milky? It's not true. It's because we have not done this experiment. That's why we keep reporting this. You can watch my video on where I do this experiment. All these things they are saying, turning lime water even into milky, is reality. But from a spatula, small spatula, you filter, they say part of the residue, not the whole residue. You now add HCl to it. It will give you CO2 enough. They said add it to, if you check where it's even in a test tube, imagine. So how will you bubble the gas from test tube into the lime water? Okay, now just watch that review. It's high time we change to assumed science. So as normal, what we are expected to report here is our inference CO2 gas from CO3 2 minus. Then that's it. Then the other subsequent ones, that's BII, they say to about 2 cm cube of the clear solution from one can also add here, like I said, white not can, you add it because that's what is obtainable. White powdery should it be a precipitate? White powdery precipitate, should that be a precipitate? Okay, remained in the solution or in the mixture, probably lead 2 chloride, which is true. So we move on there because of space. I gotta find out the other thing. I didn't snap this complete. I wasn't the person that even snapped. I couldn't get access to it. Someone sent to me. So maybe let me use this space to complete the table for let's write it complete. And they said now the clear layer, a clear
upper part,
2 cm cube of I don't know how they use that language. 2 cm cube
of course,
of clear solution
into another test tube.
Clear solution from BI as BII, if I'm correct.
Make sure
BI, yeah,
tested all these reagents.
Plus sodium hydroxide in drops plus excess. Yes, observation. From what I'm showing you there on the screen, for me, I don't notice any visible reaction. No visible reaction, and I'm not surprised. No visible reaction. I wouldn't know what to term as inference, though the normal theoretical thing you would have told your student to say is white powdery precipitate which dissolves in excess. But for me, I did not get any visible reaction, and possibly because the lead 2 chloride formed is also insoluble. The solubility of lead 2 chloride in water at 20 degrees should be about, it's very, very insignificant, and we are talking about just 2 cm cube. So I wouldn't know. Some said that precipitates occurred in their own. Mine show no visible reaction, and like I said, I'm not worried about not having any visible reaction because I cannot detect lead 2 ion in lead 2 chloride that is solid. This compound is not ionic because it's solid. So really, lead 2 ion being present in that aqueous upper layer is I don't know. But maybe this is Africa. They may not consider all these things and now report normal and come here and write lead 2 suspected, possibly even include since you say here powdery, remember, all things being equal, if you make here powdery or chalky, of which I'm feeling this based on what is obtained in the lab, I'm not feeling it based on what you want to manipulate. I'm standing in for science, so some of you that can help out and do this experiment, maybe can tell me why my result wasn't showing well. And also, if you have access to these exam bodies, maybe let's hear their own part, because I know they have experts within themselves, but experts are those that are doing this, that do this thing, not experts in title. Science respects the truth and not title. That's why Michael Faraday was able to tell professors, even the whole university then, that electricity doesn't flow inside wire, rather it flows around wire. It was a big thing, but Faraday was nobody. So show me why there should be reaction. In this case, mine did not show any. So inference, I don't know what I'll put there. But when you say, let's assume you use powdery, if you say powdery, you are just going to say lead 2 only. Lead 2 present, assuming, because it's only lead that is powdery or chalky. But when it's gelatinous, you don't put lead. So it becomes funny if your observation have powdery, chalky, and you went on putting aluminium, zinc, which are all gelatinous. But I'm not putting any of these ions here because I did not make any visible reaction from my own. I know lead 2 chloride is 100. If they have said heat the solution, that one will be understandable. If we heat the solution, so some of their lead 2 ion will dissolve automatically. But they just say add HCl. There is nothing like heat there. Okay, so I believe that 2 good heads are better than 1, not by intimidation. So your title, I respect it, but I'm just saying what is obtainable. Okay, then why don't we, if you report white powdery precipitate over here that dissolve in excess, no need of putting calcium because calcium doesn't dissolve in excess sodium hydroxide. Then they proceeded again to tell us to also add the same thing, 2 cm cube of clear solution
We only believe
from Bi plus ammonia this time around, aqueous ammonia in drops plus excess. Over here I noticed slight precipitate, but I don't know why I didn't get with sodium hydroxide. So there was white precipitate that wasn't showing the nature of the precipitate that should be formed. Well, it was a kind of showing more of the ammonia I'm adding reacting with some of the
white
HCl, giving a white dense film, though it wasn't filming so visible inside that solution. So there is still little contamination. But here there is white powdery precipitate. I'm even confused why I observed that. So what I'm saying that this white powder, it wasn't purely like a precipitate, and when I kept it after some time, I couldn't, the precipitate wasn't there after some time. Okay, white powdery precipitate which persists in excess. So since it's white and powdery, you just say lead 2 present or lead 2 still likely, because it's only HCl that will confirm lead or hydrogen sulfide, where you to form a black precipitate with lead 2 sulfide, or you use okay, these are the 2 things. So potassium iodide can also do that. It will give a yellow precipitate of lead 2 ion. So this is my own observations and the part, which means invariably, if all things work well, it looks as if WAEC should give students more bonus in these tests. What thing that marvels me is that they made mention of clear solution, so they know there is some part that will not dissolve and there is part that will dissolve. In that review, I did not see the chemistry that will put lead 2 ion into that solution at that temperature. I wouldn't know. Or maybe that lead 2 ion will dissolve in excess sodium carbonate. It is not possible. I wouldn't see why. I don't know. Okay, let's go to number 3. Okay, this is the number 3. Mention 2 gases that are soluble in water. This is more like they want to dash them mark. If you hear about soluble gases, don't forget HCl. Don't forget those fountain gases, the gases used in fountain experiment. And I have a video on this fountain experiment, all of them. These are common fountain gases used in fountain experiments. So, and I said I have videos on this fountain experiment where I've used that of HCl, ammonia fountain. So they have different colors, of course. Then there are other gases. CO2 is also soluble in water. Then name 2 apparatus that could be used to measure 9.50 cm cube of a solution accurately. You can use a measuring cylinder, 10 ml measuring cylinder. 10 ml can accurately do that. That's 10 cm cube. Then you can also use graduated pipette and also use burette. burette can actually measure that one. Burette, so graduated pipette. Don't just say pipette, because the pipette you use for titration is volumetric pipette. It's graduated that can do that. What is the use of a fume cupboard in the laboratory? Of course, it's to prepare poisonous gases. To prepare poisonous gases or poisonous substances. But it's mainly gases, of course, because the fume cupboard is to take away that poisonous gas outside. Normally, hydrogen sulfide should be prepared there, carbon 4 sulfide should be prepared there. Name 3 personal protective equipment that are used in the laboratory. That's it. Lab coats is there. Then safety goggles. Are you sure I'm getting the spelling well? Is it this goggle or this goggle? I guess this is not the correct one. Then we have the hand gloves. And then you can also have your face mask. And of course, these are personal products. You don't share them, though sometimes students may funnily share their lab coats. Okay, so this is it for this 2024 questions and answer. Thank you for watching. Remember to bring your contributions, but keep it as polite as possible and as scientific as possible, not as manipulative as possible. So watch that review. Goodbye for now. God bless Africa.
Wait a minute. Have you heard about the Majestic Table? It was designed and recommended by Her Majesty himself. Yes, it is. The amazing thing about the Majestic Periodic Table is that it provides a clear and colorful classification of elements, from P block metals to metalloids to liquid metals. It also shows the boiling and melting point of all the elements. It also has the unique feeling of electrons in the shells of each element.